Good afternoon, everyone, and warm greetings from Budapest. Let me introduce our site here in Hungary. And first of all, let me introduce myself. I'm managing director of Thermwatt, a Hungarian company owning and developing a technology for the sewage heat utilization that we developed over 10 years ago. And now we use this technology in large scale, especially for large buildings over 10,000 square meter and district level. And here in Budapest, among others, we operate even hospitals. We are the operator of the military hospital of Budapest, which is very important now these days. This is to tell you that this technology is so reliable that even hospitals can be operated with. So let's see how this technology works. And let me introduce the sewage as heat source. In any cities, we have this heat source around us because naturally using the water, we produce wastewaters that are collected in main collectors under surface, under the roads. And the special thing about wastewater is the temperature, which is in every city nearly steady all year round. Means that even in cold winters, when we may have, for example, in Hungary, minus 15 degrees or lower, or in warm summers, what we have maybe 38 degrees or 40 degrees in summer, as far as we are continental weather. So still, we have a very reliable and steady heat source, means that this heat source, the temperature is around 15 degrees Celsius. And once we are talking about efficient heat pumps, efficient heat pumping, we have to talk about water-to-water heat pumps, the most efficient heat pumps. But of course, heat pumps need heat source. And we believe that probably one of the most ideal heat source for heat pumps is wastewater, but we need to harness it. So to use this heat source, we have to have a proper heat exchange. But to manage this, we have to deal with wastewater, which is a mix of different things in a flow, and we have to separate the solids. So, as the first stage in this technology, you will see here, we conduct the flows into a screen, and this screen separates the water. So we have here filtered water. And the screen lifts up the solids, and the solids goes back to the sewer. And we use the filtered water through pumps. We conduct this flow into heat exchanger. And after heat exchange, we feed the heat pump. And once the heat pump heated up, because in heating mode heated up the building, then the cold water comes back through heat exchanger. And after this, we flush back the solids, and the colder flow goes back to the sewer in heating mode. So what happens now, that once we want to heat up a building here, we produce warm energy. In the same time, we produce cold energy. It means that we cool down the wastewater. So in fact, what happens that we use the warm energy of the wastewater to heating up the building through heat pumps, and we do the opposite once we would like to cool down the building. So what happens that we evacuate the warm energy from the building into the sewers, means that we warm up the sewer at that time. The good thing about this heat source is available anywhere in cities. And the special thing about our technology that, as I mentioned, we do this in large scale. As far as we know, we have the largest installations of its kind. It means that the installation with raw sewage in town. We believe there is a huge potential in every city for this. Just to give you an idea, the potential of this technology in a city like Budapest with 2 million inhabitants is roughly 200 megawatts. So the potential is huge. Many buildings can be operated with this technology. So let's come into the detail. And I would like to show you some information about the technology. So just Okay, come back again. So as I mentioned, here we have the sewage as heat source. Then the sewage is conducted to the shaft. Then we have a spine screen. After the spine screen, the key element is the heat exchange. Heat exchanger produce the clean water in closed circuit to the heat pump, and the heat pump produces, in this case, the warm energy to the building. So in fact, we have three steps. First is the screening, then heat exchanging, and heat pumping, as I mentioned before. But let's see how does it work in real, and what are the benefits of this technology. So here with this technology, we save CO2 emission because this is very efficient in heat pumping. But the key is here having a good and efficient heat exchange. Of course, heat exchange in this case, when we deal with sewage flow, is affected by the degree of dirt level of the flow. So it means that sometime we need to clean up heat exchangers to have proper heat exchange. So the research and development in the frame of this project was to enhance the efficiency of our heat exchangers. They were already good, but we believed that we could do even better. And for this, of course, we have to work also parallelly on the fine screen, because fine screens are made to prepare the filtered water for heat exchanger. So we did two things parallelly. We made better heat exchangers, different types, and we made better fine screens, nearly maintenance-free. Because all this has to work by distance, has to work on-site without any people, and has to be automized. So we develop here a nearly maintenance-free solution to this technology. And then the problem was in a heat exchange that in the in the heat exchanger we had the sludge that can appear on the surface and the inner part of the heat exchanger. So here we have the screen, and for the screen we developed a cleaning system. It means that we invented here a water cleaning system to release. You can see this part here around to release the sludge residues on the on the screen to have a proper and good filtration for the project. I would like to bring you on site. So let's see what happens here in Budapest. Here we have our customer, which is a municipality, District 4 of Budapest. This is the municipality building. This is the mayor's office. They have also, as there is a state building called government building. They produce passport, ID card, and so on. And here they built a new market hall. So there are basically three big buildings built here in St. Stefan Street in District 4 in Budapest. And to visualize better, you may see that the buildings are not so far. And the good thing about this location is there, the blue line is wastewater collector. And this collector, we have a heat source. I will come to this volume, what we have here. And we designed here a heating center to heat up and, of course, cool down the three buildings around. If we move to the layout of this site, there we have to double check, of course, the flows, because this is our heat source. And the flow in summer, for example, of course, it's much lower by night, because people, they don't use their washing machines, dishwashers, toilets, and so on, than in daytime. But we have to, of course, produce heat even nighttime if it's needed. So we concentrate on the low flows also by night, and with some storage, we can equalize this for the whole day. And here we have a daily average of roughly 18 to 20,000 cubic meter a day, so roughly 500 cubic meter per hour, coming from a collector here, which is just nearby of our site. So next to this collector, we built a big underground structure. And within this structure, we built a deeper part, which is our shaft with a screen. We put in the heat exchangers, heat pumps, and we connected this to the market hall and also to the municipality and government window. So let's see how does this look like, our buildings. So here you see we have three different kind of buildings. One is very old, this is the mayor's office, a completely new one, the new market hall, and the government window. If we compare those buildings, they are very different in size also. Here we have a relatively small, but still 2,600 square meter mayor's office, which was built over 100 years ago. And a relatively new 20 years old government window, and a completely new market hall, which is a big one, 8,000 square meter, also including concert halls, cinema, and other spaces. And then, if we look at the layout of the system, we designed a system. There we have heating central with wastewater screening and heat exchangers and heat pumps on the side that I've just shown to you before. And here we produce in our heat exchangers the closed loop clean water that can feed heat pump. But for the reason to have a better efficiency in transport of the heat, we put another heat pump into the market hall, which is a big consumer in the system. So we have two heat pumps, and one is in the big heating and cooling center. Other one is under the new market hall. Here you see the elements. So the first is the screening units. Secondly, then you have the heat exchangers and two heat pumps in two different locations. And then on the design, you see that here we have very compact design to use under very valuable underground spaces. So we use spaces in an efficient way. And here we produce as maximum energy as we can for this project. You see that the site was existing for operation and was very ideal to put next to the older heat exchanger, the new heat exchangers, very similar in size but very different inside. And compare the efficiency of the new heat exchanger and compare the efficiency of the old screen and the new screen. Once we done the design, we started, of course, the construction. And here we built, we reopened this underground structure, which was under the yellow bricks here in the main square of this district. And then we built in our screen, but before that we had a shaft cleaning by the operational company of Budapest of Sewage network. And here you see that we opened and rebuilt again this parking, and we built in the new elements of the technology, including the new heat exchangers that you can see here. And the built-in heat exchangers, and after you can see the screens also. The new screens includes, as I mentioned, the water cleaning system, having better efficiency and maintenance-free solution here. And also, parallelly, we developed a SCADA system, a proper SCADA system to this, including the elements where we measure the flows temperatures, so we can calculate the efficiency of the system, and we collect the data, the digital data in computers. The system, once is designed, so this is the new design, is supervised by us 24/7. So we collect all the data, and as far as we are operator, we operate 24/7 this site. And here we see all the temperatures for the heating. This is a heating mode, and all the condition of the heat pumps, and of course also the heat exchange. And we collect those data, and with the collaboration of Polytechnico Milan, with our colleagues there, we evaluate those data, and what we see that we have some result already, because this monitoring started last October. So here we see that the data in some way, for example, this one, I'll just come back here, yes. What we have foreseen, the flow of wastewater and the temperature that corresponds, that it was foreseen. So here you see that from 15 degrees Celsius, the gray line, the steady gray line is that it was foreseen. So it's not exactly 15, but very close to 15, what we have here. And on the orange and red line, you see that after heating, it means that if we cool down the wastewater flow, it's nearly 10 degrees Celsius. That means that as it was foreseen, nearly exactly what happens, that 5 degrees Celsius, we modify the temperature, that allows us to produce heat from the wastewater flows. And coming to the end of my presentation, what we have achieved here. So we proved that there's no necessity to provide separate heating and cooling. For example, right now where we have Budapest roughly 18 degrees Celsius, you have seen that this market hall with many windows, we provide cooling. Whilst we have cold nights and still provide warm energy to the mayor's office. So we can provide heating and cooling even parallelly in this the network coming from the wastewater. And we realized savings coming from the fact that this technology is much more efficient than traditional heating with boilers or even district heating. And we could completely eliminate the use of fossil fuels. Initially, the mayor's office and government window was heated by gas boilers. No, they don't use this at all. And even the sanitary water comes from our technology. Through this solution, we built a very good relationship with the District 4. Even the mayor visited our premises in last February. And now we are part of the very positive communication of this district that using renewables, because sewage is from end of 2018 is renewable, corresponding to the Renewable Energy Directive 2 of the EU Commission. So it's a new energy source, not much use, but it's a renewable energy source that we can use, and we turn completely this district into renewables. So here we prove that we have a more efficient solution in screening, more efficient maintenance in screening, and more efficient heat exchange. So we believe so far, having the data, that we achieved our aims in this Heat4Cool project. And thank you for the collaboration of the other companies working with us. So if you may have some questions about this great technology, just feel free to ask me at the end, or even having my email here. You can send me an email if you are more interested. So thank you for your kind attention.